Okay, guys, we're gonna move on now to Matplotlib. Matplotlib is just visualization library. The visualizations are not interactive, but they are very simple to create, and it's a very powerful module. So that's the one that we're gonna like consider as being the default here for the course. And basically, you import it. So I'm importing it like import matplotlib.pyplot as PLT. I won't talk too much about this, but basically pyplot is a submodule of matplotlib, which is the module that we're going to use for this notebook. And I'm renaming it as PLT just because PLT is easier to write than matplotlib.pyplot. And the reason why we're using this specific submodule of matplotlib is because it gives us a little bit of an easy interface to work with. So this is the one I'm going to use. There's a lot of other stuff you can do with Matplotlib, of course, but this is just supposed to be a very quick introduction, right? The easiest way to create a plot here is to call plt.plot. As you can see, this is kind of like a Swiss Army knife. It lets you do a lot of stuff. Just take a look at this code, for example, where I'm plotting. I'm creating this Y array by calling this random.rand function from NumPy that creates an array full of random numbers, and I'm asking for 10 random numbers in this case. So that's what you see here. It's an array with 10 random numbers. This is an interesting example here of vectorized operations. So you can see that I'm summing 2 to the array. And the reason why I'm doing this is because if I just call like this, I get numbers between 0 and 1. So if I just do it like this, I say, okay, give me 10 random numbers. Since NumPy doesn't know like what random numbers I want, then it just gives me random numbers between 0 and 1. And then I can, for example, sum 2, and then basically now my numbers are basically between 2 and 3. It doesn't matter. It's just an example of a vectorized operation that you can do here. And then I plot it. And it couldn't be easier. I mean, just look at this. It's super mega easy. So I'm just saying plot the array of Y, and then I'm giving it a little bit of a format specification here. I'm saying I want to use circles and I want to use lines. So for example, if I do it like this, then the circles are gone. And actually, if I didn't do anything, this would be exactly what I would see anyway, because by default, Matplotlib just supposes that I'm doing a line plot, right? But if I do something like this, then I'm saying I want lines, but I also want circles. And if I actually just gave this, then it would be only points and not lines anymore. So you can see how this is super flexible. You can do a lot of stuff. This is actually very similar to what MATLAB has. If you ever worked with MATLAB, you are familiar with this. It's basically the same. Yeah. And as you can see here, one interesting thing is that I did not have to define the x-axis here. So basically NumPy just assumed the x-axis here as being like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Because I didn't give it to it. I didn't say anything, so it just assumed. But I could have given some other specification here. Let's try to make something a little bit more interesting. Yeah, so basically here what I'm doing is I'm creating a T array here. And the way I'm creating it is by calling this function called aRange, which is basically I'm saying I want numbers between 0 and 5, and I want them to be, in steps of 0.2. So basically I have 0, 0.2, 0.4, 0.6, 8, 1, 1.2, and so on and so forth until I get to 5, but not including 5, as you can see here. It stops at 4.8. So beginning, end, step. And then I get this array here, T. And now I'm plotting 3 things. And this is an interesting thing for you guys to know, that when you're plotting using plt.plot, you can simply call plt.plot multiple times, one after the other, and they will be basically stacked on top of each other, okay? So for example, here I plotted T. Actually, you know what? Let me comment this and show you how it works. So first I plotted T, and I defined that I want it to be red, and to be dashed, so a dashed line. And then this is what we see, right? Basically, because I mean, this is just evenly spaced numbers. And then I said, okay, I want to plot now t squared, right? So t to the power of 2 here. And please remember here that this thing here, this is not like a function call or anything. This is actually t squared. So if I were to actually do something else like t, I could call it t2 like this, and I can print it, and you can see that this t2, you know, let me comment this. T2 is actually an array. It's not that I'm defined that I want t to be squared or something like this. I'm actually squaring all elements of t and making a new array out of that. So then you have 0, 0.04, 0.16, so on and so forth. But I just wanted to you guys to make sure you understand that when I call this, this is an actually new array that has all elements from t squared, okay? And then you have this, and now you can see that we have two things here, stacked on top of each other. And then I do the same thing, but now I want t to the power of 3. And I specify that I want it to be green. I want it to have little circles, and I want it to have a line. And then you see the results here. So basically, 3 different plots stacked on top of each other in the same figure. And always remember to call plt.show, because this is what allows you to stack these 3 plots on top of each other before you call plt show. The moment you call plt show, basically they're like offloaded or something. If I were to do something like this, then it would work a little bit differently. You see, if I do plt.show and then I do something else and I do plt.show again, then you see the first one and the second one. Because every time you call plt.show, you're basically saying, okay, do it. And then let's start again with the next one. Right. Yeah, these are the stuff that I've seen. Yeah, the syntax formats for these things, I'm not going to go over that. You can look that up in the documentation. There's like millions of different syntax that you can use here to define all kinds of different symbols and colors and so on and so forth. I won't, of course, talk about that, but you can look at the documentation for a full description here. Actually, if I open here, you can see that somewhere. Notes, I think it's I think it's here. You see this one, notes, format strings, and then markers. You have a bunch of different markers, line styles, colors, and so on. So you can take a look at that later and then go crazy with this. Oh yeah, and of course we can add legends to this, because without a legend this looks completely horrible. And also titles to the axis and so on and so forth. So if we take the same thing I did before in the first one, and one thing that I added here was I'm calling after I plot, so I plot t and I give the format, and then I say label equals t. This label is what goes into the legend over here. So t or t squared or t cubed, this is what goes into the legend over here. And then you call plt.legend. That's it. That's all you need to do. And then the legend appears. Actually, you know, I'm going to comment this and then show it to you. Yeah. So you see, this is exactly the same as we had before, with the addition that I added a label to each plot, and then I called plt.legend, and then it puts the legend over here. And you know, if you don't say anything, I want the legends to be here or there, then it just kind of like looks for the best possible place to put it. But sometimes it's not very good, so then you have to actually specify it yourself. Unfortunately, I don't have time to talk too much about this, but who knows, maybe next time. And then I define some other stuff here just to make the plot a little bit more beautiful. I put the title, Matplotlib example, and then it appears over here, as you can see. Then I call X label and Y label in order to define labels for the axis. So you can see like the X label is T because that's what it is here. And the Y label is, I just call it FT because it's some function applied to T in the Y axis, right? And then you see it here. So just by looking at this, you can see that, you know, very easily you can make 99% of the plots you're going to need for the whole course, just by going up to this point, to be honest. Right, okay, cool. Evan made a comment here saying that these look a lot like MATLAB, but in MATLAB you have to hold on if you want multiple lines in a plot. Yeah, I'm not very, I know a little bit of MATLAB, but it's been a long time. Right, so up to this point, like I said, you could do probably like most of the plots you need to do for the entire course just by going, just by using this. There will be cases where when you will have to customize a little bit, but the truth is that most of the plots could be done just by going up to this point. David asked what was that show again, and yeah, Ali answered. Yeah. So basically, when you, David, when you call plt.show, you basically saying, okay, offload everything that I've done so far and then start a new one. So for example, if we go back here and I took this call of show here and I put it here, for example, then you're going to see two plots. The first one has the first two and the second one has only the third one. Yeah, I guess. Yeah, I don't remember the MATLAB calls, but I guess, yeah. So I'm going to skip this one because it's not super important. You can make bar charts very, very, very easily just by calling plt.bar instead of plt.plot. So you could use this to do like to I don't know, to put scores, for example, for different models. And the way you do it is you just make a list with the stuff that you want to have in the x-axis, put the values here, like red equals 20, green equals 30, blue equals 100. Then you call plt.bar, x-axis, y-axis, names and values. Red equals 20, green equals 30, and blue equals 100. And I put also a list here with the colors RGB, so RGB, and title and so on. So it's also like, couldn't be simpler to do. Of course, again, if you want to do something super, super complicated and super nice, then you're going to have to dig in the documentation of each of these function calls and then find out like what are the arguments, what are the stuff, what's the other stuff that you can do. But basically, if you just wanted to do, I just want to do a very simple bar chart. Let's say, for example, red, green, and blue are three different models that you have trained. And let's say you want to compare the accuracies for these three models, then you could simply do a very simple bar chart and plot the values of the accuracies here. That would be one way to do that. And keep in mind that sometimes less is more. Actually, most of the time, less is more. So if you can do the same thing with a simpler graph than you can do with a complex graph, then go for the simpler graph. You can do histograms. Histograms are a little bit like bar charts, but they show distributions of variables. I cannot really go very much details with this, but basically the histogram here, I'm calling it with plt.hist. And I hope you know what a histogram is, but basically I'm asking for 50 bins. So there are 50 little rectangles here that show like how many points are in each of these regions. That's what a histogram does, right? And since I'm simulating here or sampling here a normal distribution, then you see a normal distribution here in the histogram. And anyway, I mean, I cannot talk much more about this, unfortunately, because we're out of time and I still have some stuff to talk about. I just hope that this example can be useful in the future when you want to do your own histograms. And if you don't know what a histogram is, then I guess you can look it up because it's a very common, very useful thing to do. Then another useful thing that we can do with Matplotlib is heat maps, which are basically like full pictures of pixels with as many pixels as you want, like with any resolution that you want. In this case, what I did here, if you look at the code, is I basically, first of all, generated an array of random values. It's a rank 2 array, has 2 axes. Each axis has 10 values, and then it's here if you are curious to know the values. As you can see, I did not do anything with the results, so it's all between 0 and 1. And I have 100 values here because it's 10 by 10. And then it couldn't, as you can see here, it couldn't be simpler. I'm calling plt.imShow, which basically is like image show. And I give X here. And then so Matplotlib knows that, okay, I gotta take X and I gotta map these values to pixels. I say pixel, but of course there are many pixels here, but let's say just it's a resolution of 10 by 10. So let's just consider that each of these is like a big pixel, right? Basically, when you call image show, you're saying Matplotlib understands that they have to take the X that you just gave it, and it will map the value of each X to a certain color. And the way it maps is by using a color map. Now, I could simply not have done anything here, and this is what I would see. And the reason I would see this is because this is the default color map. It's called Viridis. It's a very good color map, actually. If you guys want to use it as a default, there's absolutely no problem with that because it's really, really good. So that would, you see, that it couldn't be simpler than this. Literally, plot plt.imShow X, and then you have a heat map here. Period. Right. So that's super, super, super simple. But of course, in my case, I said, okay, I want to change the color map because I want another color map. So I'm using this color map called Plasma, which is available in this module here, matplotlib.cm. You know, because there are many of them. I left a link here to the tutorial for color maps in Matplotlib, and really take a look at this because this tutorial is one of the most amazing things that you can read about color maps. It's amazing. So really take a look at this tutorial on color maps because it's really, really good. And then that's how you do a color map. There are many ways, there are many things you could do with this. Like for example, in this case, as you can see here, like since I made a much larger array here, because now we're talking, I have an array that is 100 by 100. So the picture looks much better than the previous one, right? Because this looks very rough, but this one looks actually quite cool. So this is just a way to show a picture given that you have an array. And in this case, for example, I just generated this array by computing the distance from each cell to the center of the matrix. So basically, I have an empty array here of n by n, and then I go through all the arrays that I have, and the cells of this array, and I compute the distance from that specific cell to the center, and the center in this case is just n divided by 2 because this is n, and this is n divided by 2 in both axes. And this is what you see. So you can see this in this case that it is very bright in the center and very dark towards the borders because this is the color map that I'm using. I'm using this color map called yellow, green, blue. So basically means it starts with yellow, passes through green, and then goes to blue. Okay, so this is why we see it like this. The larger the distance from the center, the larger the value of the color map. And this color map happens to go like this. And I could do something different. I could call it like plasma, and then you would see a different thing because you're mapping the values to different colors. And in this case, plasma goes from dark purple to yellow. So that's why you see like low values, large values. Okay. And in this case, you see that I defined the color map here in a different way that I did here. Two different options. You can do both. I just like to show different possibilities for you. Right. And then I was asked by Jonas to talk to you a little bit about how to plot decision boundaries. And the way you plot decision boundaries is by using this imShow method, because I don't know, probably you've never seen a decision boundary. So let me just show the picture first of all. This is what a decision boundary looks like. It's a way to say, look, I have all these points, and these points are like points that I want to classify. And then I want to plot the decision boundaries. And to plot the decision boundaries, I have actually to try to classify all the points in the grid to try to predict which class they are from, right? So if you've seen a little bit about supervised learning, then you know that supervised learning means you take some data and you try to predict the class of that data or the label of that data, right? So in this case, if we consider the classes or the labels as being just like blue or red, then the decision boundary here would basically say, okay, what if I tried to classify all the pixels in this map here? How would they be classified? And this would be like the result of this. It's a kind of it's something that you guys gonna have to do throughout the course. And I was asked to show you how to do it. So I will send you the example later so you can take a look at this and you will see how I'm doing this here using actually imshow, because imshow shows the values for all the cells of the grid, right? So I'm just gonna leave the example here. You can take a look at it later. And then we move on to scikit-learn, because there's a lot of stuff to do to talk about scikit-learn, which is much more interesting than this. Finally, subplots also is something that I think is very important. You guys are gonna use it a lot. So basically, in the same way that we did before, where we had the show and we could, well, anyway, before I showed you that if you call show a few times, then you get new figures. In what you can do with subplot is to actually arrange these figures in a grid in a nice way so that it looks better than simply having a lot of individual figures hanging around, right? So subplots will allow you to generate many different figures and put them in a nice little organized way. And the example is here. You can take a look later. I think it's very self-explainable, but basically you call subplot, and then this 131 here is very interesting because it means 1 row, 3 columns, and the current subplot is the number 1, so it's this one. And then you plot it normally, and then it appears here. Then you call plt.subplot 1, 3 again, because it's 1 row, 3 columns, but the current one is number 2. So then you do whatever you want here, and then it appears here because this is number 2. Then you go to the next one, you do again 1 row, 3 columns, number 3. So it's this one. And then you plot everything you want, and then it appears here. And when you call show, everything gets drawn at the same time in this grid that you defined. And the way that you defined it was simply by calling this 1, 3, 1, 1, 3, 2, and 1, 3, 3 before you started plotting each of the subplots. Couldn't be simpler. Take a look later. Try to do this. If it doesn't work, let me know if you have some problems. But it literally couldn't be simpler than this. And then I left here also a very nice example of a scatter plot matrix, which is using subplots. I will not talk about this now, but it's something that you guys might, if you're curious, take a look at the code of this and to have a good example of how to use subplots to do something that's very, very complicated, but also very nice. And that's it for Matplotlib for now. I will jump now to scikit-learn because also Yunus asked me to talk at least a little bit about scikit-learn with you before assignment 1, because apparently you have to use scikit-learn for assignment 1, even though it's very, very little, but at least you should know the very, very, very basics of scikit-learn. Can you plot functions directly, or do you need the data set? I'm not sure what you mean by that. Do you mean I would pass a function into the plot and the plot would call that? I don't think you can do that, no. Yeah, okay. No, you cannot do it like that. I guess in MATLAB you might, but not here. Actually, here you're always plotting the data set, yes. But I mean, it would be perfectly fine, for example, if I had some kind of function here where I take the array X and then I square it, for example, like this, right? So let's say I have a function here, fx, or like square x, and then I return x squared, and then instead of t squared here, I will call like square t, and the function, the results here are the same, right? Because actually square t returns t squared. So then I just call it here, and that has the exact same result. But what you could not do is like something like this. This you cannot do. Then you have some weird error here. I couldn't just give the function and say plot this function. You know, I have to actually say like which values of this function I'm plotting. And in this case, I'm plotting t. So yeah, I could. I'm even gonna leave it like that as an example. So yeah, you could do this if you want.